Okay, so what was the question again?
How did you know to make negative 12 over 5? Like, how did Gina make that negative?
This one. Okay, very good. The inequality has to be read. I don't want you to memorize stuff. Some things have to be memorized, but not this. So I read the inequality. It says, find those numbers whose distance from 0 is 12/5 or more. How do I present to the left-hand side of negative 12/5? Less than negative 12/5. How do I present the right-hand side of 12/5? Greater than or equal to 12/5. Okay, very good questions. Anything else here? Do we need another example? Do we need another example? Yes. With the absolute value? Okay, very, very good. So let's look at 68. 68 is 3, quantity x minus 1 over 4, everything in absolute value, less than 6. Okay, ready? So I'm looking at this inequality, and I read it. Whatever has the distance from 0 less than 6. Less than 6, greater than 6. Which one is it? Less than. If you say less than, then you can do this. If you say more than, you cannot do this. If you say more than, you have to have two different inequalities. But if you say less than, you can do this. In one chain, one compound inequality with the end. This one is a compound inequality as well, also with the a conjunction or. Okay, so what do I write for this?
Negative 6.
Very good.
And 3 parentheses x minus 1 over 1.
That's it. Now, if this were greater than, what would you have said? If this were greater than 6, what would you have said? To the less than or equal to what? Yes. No, not equal to. Less than negative 6. And the other one would have been? That's it. That's the only difference. There are only two types. Okay, what do I want to get rid of first?
4.
Yes, exactly. I want to multiply everything by 4. Or 4 over 1. So 4 over 1, and I do this. I want to simplify first and not multiply, and then multiply. So the left-hand side is negative 24. Remember, we cannot pick and choose. We have to multiply everything, all three sides. Less than, what is left in parentheses? Right, so let's distribute. Okay? Very good. Although we could have divided, it doesn't matter really. Okay, so now what do we get rid of next? Very good. So negative 20, so we are adding 3. Yes, you're right. So negative 21, we're adding 3. Less than 3x, less than 27. I'm going to make sure that this is clear that it's 1.
Sorry for that.
Good. So then we divide by 3. So this is negative 7 less than x less than 9. And can anyone give us the interval notation, which is right there in front of us? Please do not separate this type of inequality into two separate ones because you will forget to intersect. So this one has to be as a chain. The other one cannot be as a chain. Okay? So this is x is in the interval. I have to have parentheses on both sides because I don't have the equal symbol. So negative 7, 9. Do we agree with this? Do we need other examples with absolute value? If you say yes, please feel free to choose. If you say no, we'll move on. Yes, please.
So why are you adding 3 to negative 24?
Because I want to get rid of this. So I add here So I owe you $24 and I give you 3. How much do I still owe you? Yes. And then I add 3 here and I only have 3x. And then I have to add here and I have 27. So if I add, I have to add to all 3 sides. I add because I want to eliminate this. Then I divide all 3 sides because I want to eliminate this.
Okay.
And when I divide everything. Negative 21 divided by 3, 3x divided by 3, 27 divided by 3. Because I'm looking for x, plain x, x alone. Good, very good questions. Anything else? Are we okay? Do you think we need another example, maybe from the previous one or not? Or we move on? Yes, please. Which one? Please choose. You want the one that is more difficult, or you want the one? Okay. So let's choose. You can choose 76, for example. You can choose 86. You can choose 75. You can choose 77. Any preference?
77.
77. 3 minus 2/3 x. 3 minus 2/3 x in the absolute value greater than 5. Once I read the inequality carefully, I will know where to find the solutions. Let's read it. You don't have to read it with me, but just read it in your mind. So I'm looking for whatever whose distance from 0 is greater than 5. Once you say greater than 5, then you have to be outside. If you say less than 5, then you have to be inside. So obviously this is the most difficult of the two. And I cannot put everything in one chain. It's not allowed. So I have to have 2 separate inequalities that I have to solve. Anyone dictates? So obviously 3 minus 2/3 x and 3 minus 2/3 x.
Greater than 5 and less than 5.
And less than?
Negative 5.
If I put less than, greater than 5 and less than 5, then I include the inside. And I cannot do that. Is this clear with everyone? Yes, better? Okay, so again, don't be afraid of fractions ever, please. We can get rid of them very easily. So let's take the first one, 3 minus 2/3 x greater than 5. I recommend move this 3 to the other side first, and then get rid of negative 2/3. So if I move 3 to the other side, what do I get? Negative 2/3 x greater than? Very good. And then because I want to eliminate negative 2/3, what should I multiply both sides by? The multiplicative inverse with negative though, right? So 3/2 with minus in front. So negative 3/2 and negative 3/2. What is the left-hand side? Very good. That's what we wanted, to eliminate just that. So this is x. And I have to think for a moment. Don't write the symbol for a second. And then we'll simplify 2 with 2. And we will get negative 3. So 2 simplified, and you get negative 3. But now I have to think. Say it again. Yes, we multiplied both sides by a negative number. Multiplying both sides by a negative number requires switching the symbol of the inequality. And now how do I write the interval notation? I'm not done. Sorry, I'm sorry. Sorry. So let's solve the other one. 3 minus 2/3 x less than negative 5. Same step. I have to subtract. Very good. Negative 2/3 x less than negative 8. And I have to get rid of the same thing, which is multiply by negative 3/2, multiply by negative 3/2. The left-hand side gives us, the right-hand side gives us, yes, because I simplify by 2, so I get 12. But now I have to think. Do you all agree with greater than? So now, for this type of inequality, the solution must include the union. If I don't get to write the union, something is wrong. Okay, ready? So, can anyone give us this? We have to start with the one less than, and then we continue with the one greater than. The one greater than has to be here, the other one less than has to be here. X in the interval.
And -3.
Do we all agree with less than -3 is between negative infinity and -3? Accepted? So now this one, greater than 12, must be between 12 and infinity. Is this clear? Okay. Do we feel a little bit better about absolute value inequalities? Yes, please.
So when I did like, when you subtract 3 from 5, you get 2, and we're supposed to multiply by -3.
Which one are we looking at? The first one or the second one?
The one is greater than. So.
This one here?
Mhm.
This one?
Yeah.
Okay. So you subtracted 3?
Yeah, and then you got 2,
Yes.
and then you're supposed to multiply by -3, right?
You can, and then you have to divide by 2. Yeah, let's do that.
Because I got a positive 3 instead of a negative.
Very good, very good. So let's look at just that. Very good. So you, instead of eliminating negative 2/3, you eliminate it in 2 steps. You first eliminated the -3 if you want, and then you eliminate the 2, correct? Okay. When we have negative 2/3, only one of them is negative, not both. Be very careful. That's why I prefer eliminating the whole number so I don't make that error.
Right.
So negative 2/3 does not mean -2 and -3. It means either -2/3 or 2/3. Is that clear, or should I still do it? Perfect. Anything else? Anything else? Okay, this is the end of chapter 1. Now we are ready to start chapter 2. So before we start chapter 2, however, I do want to go over, and I'm looking for the document. I want to go back to one of the documents that I gave you, which is on factoring. So I want to look at that for a moment. And I do have it. So everything from chapter 1 should be completed between now and Tuesday, please, so we don't fall behind, so we can move on, okay? Now I would like to talk about this document. And this is proof why factoring is so important. So this was one of the documents that I gave you on the first day of class. You should have it. Please bring it with you.
So you even want like equations done and everything?
Everything.
Because on my math lab, it says it's due I think like the 26th or 27th.
It has to be due on Tuesday. Once we finish sections, the sections that we're completing in class, it has to be due on Tuesday.
So all the homework's in the due.
All the homework will be due the moment we finish. The next time you should have it done so you can ask questions. Otherwise, we will not be able to move forward.
So don't pay attention to the due dates on
No.
my math lab?
No.
Okay.
No. Once we announce that the section is done, you should work on it immediately. But remember, the first layer is to redo the problems you do in class. The second layer to look at the examples and the problems in the book that are recommended using this. Right? And then the third step is whatever we have in my math lab. Because otherwise you will stumble from the first problem in my math lab. Is that clear? Yes? Okay. So, as I mentioned there, when you look at this document, it's very beautifully done, but it's very difficult to read. So the problems are there on the last page. If you look at this document and you say, I think that the method from here is easier, or I learned something from it, and I was able to read it, and something else is better for you, use it, please. So now from the top, so these are the problems, and these are the answers. So please choose any problem you would like to work on first. 1 through 7. because this will be due on Tuesday. So I like to work on a couple of problems so we can finish this. And this is due on Tuesday.
The whole packet,
There are 7 problems.
the 7 problems of the Tuesday.
That's it. This is the theory. You can read it or not. So just 7 problems, and we are gonna solve 2 of those today. So what they're due is just 5 problems are due next week, next Tuesday. Okay, so please choose.
6.
Okay, so let's look at 6. We have 2. X minus 4. I'll erase that. 2x plus 7, everything cubed, minus x minus 4 squared times 3 times 2x plus 7 squared times 2. Everything divided by 2x plus 7 to the 6th power. Good pick. Any questions so far? Yes, ladies, go ahead. Did I say something?
No.
But I may have, so you can correct me anytime. Okay. So let's read the problem one more time. 2 times x minus 4 times 2x plus 7 cubed minus x minus 4 squared times 3 times 2x plus 7 squared times 2. How many terms do we see in the numerator? Exactly 2. That's why I read it one more time. This term minus this term. Why? Because these are products. They're all multiplied. It's one term. These are all multiplied. It's one term. Very good. Awesome. Thank you. Okay. Next question for you. If you look at this first term and then look at this second term, which of these two needs a little bit of work? Or maybe a little facelift.
The second.
Exactly. Why? We don't like to have factors like this in the middle of a chain of products. So I'm going to multiply these two. I get what? And I'm going to put it in front. Very good. Awesome. 2x minus 4, 2x plus 7 cubed, minus 6, x minus 4 squared, 2x plus 7 squared. Very good. 2x plus 7 to the 6th. Let me show you, maybe I shouldn't, but let me show you a terrible mistake. If I simplify 2x plus 7 squared with 2x plus 7 to the 6th, I will basically prove that I know nothing about algebra. Here's why. Because this is a piece from a term, and this is a factor. We cannot simplify a term with a factor. So don't be tempted. Good. So once I identify that the numerator has 2 terms, I am going to ask you, do they have anything in common? So here's what I do. I look first at the numbers. Do they have a greatest common factor? Is there a greatest common factor here? 2. Is there a greatest common factor here? Yes, and we'll decide upon exponents in a minute. Is there a greatest common factor? Yes. Good. So we identified 3 factors that are present in both binomials. I should say terms better. In both terms. Okay. I took from this first term, I took 2 out. Gone. I took x minus 4 out. Gone. I did put the power without thinking and without asking you and without talking about it. So allow me to go back. So 2 is very clear. I have the power on x minus 4. I have power 1. On x minus 4 here I have power 2. I have to choose the smallest power, which means it's power 1. Then I'm looking at 2x plus 7. This is power 3 and this is power 2. I have to choose the smallest. That's the reason why I have 2. And now I'm asking myself what is left in brackets. From the first term, 2 is out, x minus 4 is out, and how many of these are out? 2. From 3, 2 are out, so there is 1 still left inside. So I have to write 2x plus 7 inside the bracket. 2x plus 7. How do I check whether I'm correct? Here's how I do it. 2 times x minus 4 times 2x plus 7 squared times 2x plus 7. I get this. I reach the stage where I have to write minus. Now I'm asking myself, from 6, I got out what? So what is left inside? Very good. From x minus 4 squared, I took out an x minus 4. How many x minus 4 are still left? 1. From 2x plus 7 squared, I took out 2x plus 7 squared. Is there anything else left? No. Very good. The last step we have to perform, I shouldn't say the last, is simplify this. And now I can do this. Which power? 4. I removed 2 factors of 2x plus 7 from the top. I have to remove exactly 2 factors of 2x plus 7 from the bottom. That's why I'm left with 2x plus 7 to the 4th. So now let's simplify this, distributing and combining like terms. So this is all based on factoring. Not exactly the same type of factoring we look at trinomials, binomials, but close to polynomials. So I have then 2x minus 4, and in parentheses 2x plus 7, but minus
3x.
Plus, very good, and 2x plus 7 to the 4th power. I have to combine like terms, and I'm done. 2x minus 2 times x minus 4, and what is left in parentheses? Yes, plus. Remember, I do insist, but I do not, for this particular example, I will not deduct points. I do insist that the negative leading coefficient is out. So 2x minus 4, and please tell me what you get in parentheses after we factor out negative 1 from this binomial. And I put it in front.
X minus 19.
Thank you very much. X minus 19 indeed. And that's all we need to do. Now, the answer is presented as 19 minus x or negative x minus 19, or negative x plus 19. I recommend this with minus in front. This is correct, this is correct, this is correct. But I think this is the best. Okay, we can choose one more, and then I'll let you finish the other 5. And I'll prefer choosing now not 7, because then you're going to have something similar to work on, but choose one from 1 through 5, any one that you like. 5 it is. Any questions for me? Before we
Leave that up to Rick.
Sure. Any questions? Any questions? Do we understand the steps? Okay, let's work on this one, number 5. So 5, 2x minus 3 to the 4th, x squared plus x plus 1 to the 4th, 2x plus 1, and plus x squared plus x plus 1 to the 5th, 4, 2x minus 3 cubed times 2. Of course, I'm going to ask the same question again. How many terms we see here, and if they're both cleaned up? And the answer is, I should have not said both. I should have waited for you to answer. How many terms we see? 2 terms, some product plus another product. Are they both completely cleaned up? This is completely simplified, but this is not yet simplified. I see some factor in the middle, another factor at the end. So I will copy 5, 2x minus 3 to the 4th, x squared plus x plus 1 to the 4th, and 2x plus 1. I don't want you to fall behind. Always stop me if you think that I'm going too fast. Please. how are we going to simplify the second term?
4 times 2.
Yes, and put what in front?
8.
Very good. So this is x squared plus x plus 1 to the 5th, 2x minus 3 cubed. Okay. Now I'm going to ask myself, what do these two terms have in common? And I can no longer say that they have a common, not a common factor in front, because 5 and 8, no common factor. I see 2x minus 3 to the 4th in the first factor. In the first term, do I have a 2x minus 3 in the second term?
Yes.
Which power is the smallest of the two? So I have 2x minus 3 to the 3rd. Now I continue looking, and I see an x squared plus x plus 1 to the 4th in the first term, and I also see an x squared plus x plus 1 to the 5th. And I have to choose that because it's present in both, but the question is, which power will I choose? 4. There is nothing else common. The first term has a 2x plus 1, but the second term does not. So I found all common factors and I chose the correct power. And now all I have to do is put a bracket and see what is left. From the first term, we have a 5 left. So I have to have a 5. Then from 2x minus 3 to the 4th, I only removed 3 of those. So what is left in brackets?
2x minus 3.
So there is a 5, and there is a 2x minus 3. Then I see x squared plus x plus 1 to the 4th, but I took it all out. So from these 4, I took 3 out, 1 is still left. From these 4, I took all of them out, so they're gone. But I still have a 2x plus 1. So I have to multiply by 2x plus 1. Is this okay? Can you follow? Now I reach this symbol, which is this positive sign. 8 has to stay because I don't have an 8. I didn't take an 8 out. From x squared plus x plus 1 to the 5th, I removed 4 of those. So how many are still left?
1.
So I have to have, sorry, I ran out of room, x squared plus x plus 1.
Did you put the 8 in front of that?
Yes? Yes?
For the last one.
Yes.
You left the 2 in the front. So for 6.
You mean the
why-
previous problem?
Yeah, why are we not moving?
This one here?
Yeah.
Because I have a 2 and I have a 6 and they have a common factor, which
Oh.
is 2.
Okay.
But 5 and 8 don't.
I missed that.
That's okay, no problem. So we are back here. So from the second term, 8 has to stay. One of these two is there. But what about 2x minus 3 cubed? Nothing, because I took it all out. Are you okay, everyone? Any questions? Can you follow? Okay. So now I do have to work hard. I shouldn't say hard, but I do have to work on this and simplify it. And the rest is done. So first I recommend let's distribute this and then distribute 5. And then distribute 8 here. So I have to copy everything again. 2x minus 3 cubed, x squared plus x plus 1 to the 4th. I recommend leave the 5 alone for now. Or we can do it in one step, but I recommend let's do it in 2 steps. I will distribute 2x to 2x, 2x to 1, negative 3 to 2x, and negative 3 to 1. Then distribute 8 to these 3 terms. And then distribute 5. So 2x times 2x.
4x squared.
Very good. 2x times 1. Negative 3 times 2x.
6x.
And negative 3 times 1.
Minus 3.
Close the parenthesis. Plus 8x squared plus 8x plus 8. I will combine like terms and distribute 5. And then combine like terms again. It's a lot of writing, but once you see it, you can't miss it. Two x minus 3 cubed, x squared plus x plus 1 to the 4th, multiplied by 5 times 4, bless you, 20x squared. This is negative 4x times 5, negative 20x minus 15 plus 8x squared plus 8x plus 8. Are we in agreement with this so far? So here's what we did. Yes? So 5 times 4x squared is 20x squared. But 2x minus 6x, I combine them into negative 4x. And negative 4x times 5 would be negative 20x. I just didn't want to write it one more time. And then 5 times negative 3 is negative 15. So now finally, we have 2x. This is the final form. X squared plus x plus 1 to the 4th. We combine like terms. 28x squared minus 12x and minus 7. And this is it. A lot of work on this. But I think we got the idea. So please work on those 5 problems that are left. See if you don't get the answer, please we'll do it in class. But please attempt. One problem like this we're going to have on the first test and the final. Questions for me? Questions? Anything? Okay, so now we are ready to start chapter 2. Any questions? Okay, chapter 2. So in chapter 2, we're going to look at functions and graphs. Okay, please try to finish everything between 1.1 and 1.7 and bring questions to class, because I'm sure you're going to find questions. So we can solve them together. Okay. In 2.1, we're going to refresh our memory on a lot of things about graphs and functions, of course. I should say graphs of functions. Okay, so let's look at 3 sets of bubbles first. This is the first set, here's the second set, and here's the third set of bubbles. Okay, I'm just going to pick some numbers. I'm going to say negative 2, 4, and 7 in all of them, the first set. Negative 2, 4, and 7. And in the second set, I'm going to pick out the numbers. You can pick them for me if you want. Any 3 numbers. Let's also select 0, give me a positive and a negative, whatever you want. Oh, negative 6. And which one?
5.
Very good, 5 it is. I am going to choose to link these two. They're called sets. The first one, I'm going to choose to do this. In the second one, I'm going to do this. And in the third one, I'm going to do this. Since we don't want to leave this one out, I'm going to also put 7. Okay, so what did I do? I created a relationship between 2 sets, a set of values of x and a set of values of y. Okay, so these are 2 sets of numbers, one representing x values and the other one y values, also called input and good. For all of them, all these 3 situations, the first set is the input set, the second set is the output set, all of them. Okay, so I created a following correspondence. Negative 2 corresponds to negative 6, 4 to 5, 7 to 0. The question is this a function? Did I create a function or I just created a relation? And the answer is I did create a function because to each x value it corresponds only one y value. Therefore, this is a function. Each x value corresponds to only one y value. Function. Let's look at the second one. To each x value, it corresponds one y value. To each x value, it corresponds one y value. To each x value, it corresponds one y value. Is this a function?
Yes.
Correct. Last one. To this x value corresponds 5. To 7, 5. But to 4, I see a correspondence directly to -6 and 1 to 0. Is this a function?
No.
No. This is called a relation. It's still possible, but it's not a function. Now, the first set, for any of them, for functions or relations, the first set is also called domain. For the second set, what do you think? For all of them, what will be the second set called? Perfect. Because they are finite elements, I cannot use braces. I cannot use parentheses or brackets. I have to use braces because I'm listing the elements. It's like pretty similar to the set Bigler notation, but not exactly. Can anyone give us the domain in ascending order for all these situations and the range for all these situations in ascending order? For the domain, for all of them, if they are functions or relations, the first set is still domain. And the range, that's fine. Good. Any questions? What if I am given graphs and I am asked, well, do they represent functions or not? So I'm going to give you a couple of graphs to look at. So let's say I have this one. Or let's say I have this one. And let's say I have this one. By the way, we will graph in this class all these three functions or graphs. Okay, so let's start with this one. How do I know whether the last one represents a function or not?
Vertical line.
Awesome. By the vertical line test. If each line crosses the graph in only one point, this must be a function. So if this line crosses in one point and I read only one y value, this is a function. But if it happens everywhere, so this is a function indeed by the vertical line test. Very good. Who was your professor before so I can praise him or her? Well done. Okay, so what about the second one? Is it a function? Is the first one a function? By the vertical line test, this is, am I done?
Yeah.
Oh, I'm so sorry. I'm sorry. Please never let me, I just lost track for a moment. Never let me do that to you.